This video will demonstrate the details of the pressure vessel experiment for strength of materials. In this particular exercise, students will attach strain gauges to soda cans that are unopened and use the strain data to calculate hoop stress and longitudinal stress in a pressure vessel that is a soda can. After releasing the pressure from the can, students will read the strain gauge values and do the calculations to determine the pressure. The details of strain gauge attachment won't be shown in detail in this particular video. For those details, see a previous video on strain gauge attachment. To get us started, I have a soda can here that's already been through the experiment, but I want to use it to show the layout of the strain gauges. We'll be using 2 strain gauges, and typically this experiment is done with 2 students per can, each student attaching one of the gauges. One gauge runs longitudinally to the axis of the can, and one around the perpendicular to that axis in the hoop stress direction. Each student can do one of them. It's important to note that these 2 values are redundant in the sense that you only need one strain value to calculate the pressure in the can. There's a applicable formula for the longitudinal strain gauge and one for the hoop direction. So if one of the students doesn't attach one of the strain gauges correctly, as long as one of them is working, students can get a pressure reading. But ideally, students would get both readings and compare the pressure calculation from both of those, and of course they should be the same. So that's the best case scenario. These strain gauges actually have smaller pads on them than the practice gauges, and so students can have an issue. And there are cases where only one of these gauges is going to work. So this layout or this arrangement of having 2 students per can works out pretty well. I'll quickly go through the attachment myself, again sparing a lot of the details since that's already been done. One thing I will do a little bit differently is I will scribe very light pencil lines in the directions that I want the gauges to lie. It's important for the gauges to lie longitudinally and perpendicular to that. If the angle is off slightly, it will of course affect the readings, which will affect the pressure calculation. I've cleaned the area with isopropanol, and now, like I did before, I'm going to go ahead and take my MPrep conditioner, and I'm going to select an area on the can to apply the gauges. And the first thing I need to do is I need to sand off the paint that is on the can. We want to get down to bare aluminum so that our strain gauges adhere well. I finished up sanding the paint off with the MPrep conditioner, and I've taken, as we did before, with a cotton swab, and I'm just swabbing the area with the conditioner. I've done this with a couple of swabs already, so you can see that the swab is coming out relatively clean now. So I'm going to make this my last swab, and then we're going to wipe it down with a gauze pad and the conditioner. After I do that, I'm going to swab on the neutralizer and then continue on from there. And now swabbing with the neutralizer. When I get done with this step, I'll take and apply some more of the neutralizer and wipe it with a gauze pad. I've wiped it clean with a gauze pad and the neutralizer. At this point, what I'd like to do is use a fine tip mechanical pencil. I have a 0.5 millimeter pencil here, and I'm going to mark a longitudinal line for the strain gauge running in the longitudinal direction, and the line perpendicular to that as well. There isn't an easy, super accurate way of doing this, so I'm just going to use my pencil and a straight edge to do my best at scribing those lines. I've got my lines lightly scribed. We don't want to do them too dark because of course we're going to be adhering the gauge in that area, and we don't want to affect the glue in a negative way. It's important to note that as you're scribing those lines, do your best to not touch the area with your fingertips, as the oils on your fingertips could affect the glue as well. At this point, I'm going to go ahead and adhere the strain gauges to the can. At this point, I've taken one of the gauges and aligned it in a longitudinal direction. I have it mounted to the tape, remembering to keep the shiny side up. That's the side with the pads on it. I've taken the catalyst and wiped that across the back side of the gauge. I'm waiting a minute, and then I can go ahead and apply the glue. I'm about ready to glue down the second gauge. Remember to place a single drop of glue in the fold of the tape, and then wipe your finger across to spread it evenly on the back side of the strain gauge. Remember to apply firm pressure for a minute. I do 2 minutes just to be safe. At that point in time, I would let it sit for another minute or so, and then it's safe to pull the tape off. I've removed the tape, but before I do anything else, I want to make sure that I cover the grid area of the strain gauge so that solder doesn't splash onto it. That would definitely ruin the gauge. So the only thing I want exposed are the pads themselves so that I can solder to them. At this point, I'm going to go ahead and tin the pads as we had done before. Finishing up the last two. Some of the students will definitely have some difficulty at this point. These pads are relatively small, and so it'll take a couple of tries. But between the two students, as we mentioned before, they should get one of them to work. At this point, I've got two small beads on each gauge, one for each pad. What I can do now is take 2 strips of wire. Again, we use 3 conductor wire. On one end, I've got the black and white twisted together, the red on its own. On the other end, I need the 3 wires independent. That's the end that will plug into the strain indicator. I definitely need to tin the tips of the wire that's going to go onto the strain gauge. The other end doesn't have to be. Long term, if we were going to be using this a lot in a strain indicator, we would definitely want to tin those ends. They're more robust that way as they go in and out of the connector. You're going to need slightly longer lengths in this lab than the practice strain gauge lab. I've got about 1 foot of wire length here, and again I need 2 of those. I've tinned the tips of the wires, trimmed them back, and now I'm getting ready to solder down. The wires themselves have been taped down. I actually should have put the pads of this particular strain gauge on the top side and ran the wire up, then it wouldn't be running over the top of this gauge. It's not going to really matter, but it makes taping a little bit difficult. And finishing up the last 2. A couple of reminders when soldering. Remember to place the solder on the joint first and then come down with the tip of the soldering iron. And then once the solder begins to flow, drive the solder in and release both at the same time. We want to make sure that we keep all of this protected. We want to leave the tape on so that it is a strain relief for us as we move around. We don't want any force placed on the strain gauges themselves at the pads. It's a very weak area. I also want to point out that I strip back my wire and then trim it so that it's very short, as you can see here. The students may want to lay a piece of tape right next to the strain gauge in this area before placing the wire down, because if they have a longer length of conductor showing, we don't want that touching the can underneath. One thing that I did not do in the previous video regarding attachment of strain gauges is I did not take and clean the joint afterwards with a rosin solvent. And so we have a rosin solvent that will remove the flux at the joint. Flux is slightly acidic, and long term that can be an issue for strain gauge application. And what we're doing, it's not critical because we're using these just in a short time frame, but to give students a full experience, we would take the rosin solvent, apply it to the joint, and what that's going to do is it's going to cause the particles to become immersed in that, but we have to dab the joint to soak up those particles, and you can do that a couple of times. With the gauges attached, I can do a couple of tests to make sure that they are functioning correctly. These tests are not absolutely necessary, but with a multimeter they can be done pretty easily. Strain gauges that we purchased for this project are 120 ohms nominal resistance. So if I take a multimeter, I can check for that 120 ohms. Before I do that, I'm going to check and make sure that there is not a short somewhere in between the connection from one end of my wire all the way through to the strain gauge on the can. In order to do that, I'm going to set my multimeter on the mode for checking for conductivity. On this particular meter, it's in this position down at the bottom, and if I touch the two probes, I should get a noise telling me that there's conductivity or next to zero resistance. Now through the strain gauge, I should not have conductivity. There should be 120 ohms. In order to check for that, I'm going to connect one of my connections to the black or white connection on the strain gauge wire, and then the other connection will go to the red. I should get no buzzing sound. I'm going to go ahead and remove those now. I'm going to try the other one. Again, this tells me that I don't have a short, and a short would be caused by a splatter of solder getting onto the grid, or if when soldering to the two pads on a strain gauge, if you get solder that bridges across, that would cause a short also. Remember, the black or white wire is fine. They're connected at the other end. Again, I'm getting no short. The second thing I can do is to check the resistance. Remember, I said it should be 120 ohms. Most multimeters have a range of resistance values. I'm going to put it at 200, meaning I can measure anything up to 200. Same connection, either the black or white wire and the red, 120.9 ohms. That's great. By the way, color on here doesn't matter. You can flip-flop these, does the same thing for either the resistance or conductivity test. Checking the other wire, just to show you that we can switch them, I'm going to put the black on the red and the red on the black or white. 120.6. That's a good preliminary test. When I hook up to the strain gauge indicator, there's one more test that I'll do. Before I make any connections on the strain gauge indicator, I'm going to do a couple of things to set it up for these particular measurements. These strain gauge indicators are capable of reading 4 channels or 4 strain gauges. First thing I'm going to do is set it up to read only 2. At this point in time, it would be reading 3. I'm going to hit the channel button and scroll down to channel 3 and hit the right arrow button to make it inactive. To get back to the main screen, I hit Menu. At this point in time, you see 2 channels. Next thing I'm going to do is go to the Bridge button. In the Bridge button for this experiment, we want to make sure that all the channels, especially 1 and 2, 1 and 2 are really the only ones that matter since they are the only ones that I'm using. We want to make sure that they say quarter, and that stands for quarter bridge, something we're not getting into, but that's what you want for this particular exercise. Hit Menu to get back to the main screen. The gauge factor or scaling, these strain gauges come with what's called a gauge factor, and that varies depending on the batch of strain gauges that you get. Nominally, they're a value of 2, but they may range from 2 to 2.1 or something like that. If we were trying to be as precise as possible, we would want to match up this strain gauge factor for each of our gauges on channel 1 and channel 2. I'm going to leave it at that because, as I mentioned, unless you want to spend a lot of time changing this for every student that comes up to use this meter, I wouldn't worry about it. Going back to the main menu. At this point in time, it's time to connect the 2 strain gauges. In order to do that, I'm going to point out the channels that are used for this. First of all, the black and white wires have to be separate from each other. If you've connected them together on the end that goes into the indicator, you need to break those apart because they have individual connections that they're going to go into. So the red wire is going to go to P+, the black or white wire will go to S-, and the other black or white wire will go to D with the 120 under it, indicating 120 ohm. I've got the connections made now. You can see the color red, white, black, and red, white, black. Again, the black and white could be switched. I'm getting some non-zero values here on the screen. That's good. I should be able to move these wires and not see huge differences in the value on channel 1 and channel 2 doing the same. Again, we don't want to see any huge differences in the value. That means you've got a connection issue here. Make sure that you do not have the insulation portion of the wire trapped inside the connector. Of course, you will not get a reading if that happens. At this point, I want to go ahead and balance to zero out these values. So I'm going to hit the balance button. It asked me if I'm sure I want to balance, and to hit the balance button again. If I am, I want to save that, so I'm going to hit record. With my strain gauges in place, connected to the connectors, and balanced, I'm now ready to check these gauges and make sure they're properly functioning. I can do that by pushing down on the unopened can and watching the values change on the indicator. Notice that one of the values is negative and one of them is positive. That's because when I push down on the can, the longitudinal gauge gets compressed and a negative value shows. For the hoop strain, that value increases in a positive manner because as I push down, the can wants to fatten out and expand that strain gauge. So that makes sense. When I let go of the can, ideally I want to see those values return to 0. You can see that channel 2 is floating around 1 or 2. That's okay. If it's less than 8, 9, 10, it'll work. If it gets bigger than that, you want to check your connections here. I've actually ended up tinning the ends of these because it makes it easier to get a good connection. That's a lot of the times where the problem is, and so that's one thing you can check. So again, values seem to be working. When I pop the can, I expect to see both of these values be the same sign. I'll pop the can and we'll see what those are. Of course, the magnitude will not be the same. So I'll go ahead and pop the can. And I see 2 negative values. The values are both negative because the can was pressurized, and upon releasing the pressure, both the gauges have relaxed. I can now use these 2 values to calculate the pressure in the can. Again, those values are plugged into equations that are independent of each other, so the pressure that results from those 2 values, of course, should be the same. That completes the exercise portion of this lab. For details and equations of how to calculate the pressure, see the lab handout. One other thing I'll mention as we finish up, the students can keep the cans, of course, with the strain gauges, but I usually ask them to cut off the wire so we can use those next time.